Welcome to the Research and Innovation Lab, or RailTEC. We're excited to show you around. Our students leverage the research results from the lab, field, and simulation to improve upon the design and maintenance recommended practices set by professional associations that improve rail safety and sustainability. The lab has served projects funded by the Department of Transportation's Federal Railroad Administration and Federal Transit Administration. The projects have also been funded, supported, and executed for railroads and suppliers. We are working to solve real-world problems and make a difference. This laboratory and the research conducted wouldn't be possible without the continued support from industry sponsors who provide the funds for the projects, as well as our industry partners who challenge us with questions and ensure we stay on track, as well as provide materials and advice to help us successfully meet the goals of our projects. The tour of this laboratory will provide an overview of the capabilities and spotlight two of our current projects. Research performed in this laboratory investigates railroad infrastructure components at the system and subsystem level, and so these are our tools. The Pulsating Load Testing Machine, or PLTM, is a biaxial load frame on loan to us by Progress Rail. We primarily use this frame to quantify the performance of rail fastening systems and investigate how they respond to loads. The Static Tie Tester, or STT, is primarily used to investigate the structural response of cross ties through the execution of a combination of ARIMA recommended tests and novel experiments. The large-scale test frame currently provides perhaps the most flexibility for our researchers. We have used this to answer questions about joint bars for New York City Transit, concrete tie design and failure modes for the Federal Railroad Administration, and a variety of questions for companies to improve their knowledge of their products. Outdoor test track section is 70 feet long and is made up of various infrastructure components. This track was designed to serve two primary functions. First, to assist in the development of non-destructive testing, or NDT, methods for inspecting track, and further, to educate students and researchers about the number of components made from many materials that could be used in track construction. For example, from here we can see the ties can be made of timber, concrete, plastic, or steel. The concrete ties can be made in a variety of ways, and the fasteners used with these ties can vary significantly depending on their demanding locations. Therefore, the design of tracks should be optimized to meet the demands at a given location while not being over-designed. A significant thrust of our research group is to improve upon this design optimization. Our track loading system, or the TLS, is a one-of-a-kind frame in North America that has been used to investigate the vertical, lateral, and longitudinal load path through the track structure in a controlled manner. Vertical, lateral, and/or longitudinal loads can be applied to this full-depth track structure, and we are currently rebuilding the track to improve rail safety through an in-depth study into the effect of track construction on longitudinal load distribution. Now that we've had a chance to see the tools we use around the lab, now let's take a few minutes to meet the students and staff who perform the research. First is Christian Kachatourian, whose current work is aimed at developing methods to reduce the frequency of failed fastening systems.
This fixture is something that I've used for my entire year here at RailTEC, and it's got two separate actuators, which are two separate loading fixtures. This one up top allows us to apply vertical loads up and down. The one on the side here that's bouncing back and forth allows us to load longitudinally, which would be along the rail. And this is a very cool piece of lab equipment because, as you can see here, we can not only load a single spike in a spike block, but we also have a rail that we can put on and fasten up an entire single fastening system and have 4 spikes and different various types of fastening systems. And because of the broken spike problem that we've seen over the last couple of decades, it enables us to have a better understanding of how load is transferred to the spikes based on various fastening system components, tie material type, and other different controlled variables that we're allowed to play with in the lab based on the experiments that we're running.
Next, we will hear from Max Potvin about the work he's doing on the TLS.
A massive problem facing the industry right now are rail brakes and rail buckles, and both of those tend to come from when the rail undergoes temperature change. It wants to expand and contract. So what we're doing here is we're nearing completion on this track panel of construction, and so we're going to mechanically simulate the loads that we see out in the field and see how it resists and reacts to these loads. We're also going to be able to change some variables and see how those affect the resistance to the loads, such as cross-tie type, how it's fastened in to the rail, as well as how much rock is between the ties. And so ultimately what we're trying to do is help better inform what goes out in the field on how they manage their stresses.
And finally, Arthur Lima is a research engineer who helps manage our lab and field activities and can discuss some of the work that he's performing.
Here at RailTEC, we have the opportunity to work both in the laboratory and out in the field and use a variety of different equipment and sensors to measure things. So here are just a few examples of some of these equipments that we use here in our laboratory or take to the field as well. So we have geophones that measure velocity of movement, accelerometers, optical sensors like laser displacement sensors or physical displacement sensors as LVDTs, a variety of different types of strain gauges, concrete, bondable steel strain gauges, weldable gauges, and you can see one example there where we're testing one that's installed on the rail to measure vertical loads. And as you'll see, we also use a lot of these in the field, and we have some footage to show of some of the activities that we've done recently out in the field.
The work we perform in the lab is critical. However, we also enjoy the opportunity to apply what we learn in the lab and work with our industry partners and sponsors to instrument revenue service track to collect data subjected to real-world operations. Thank you again for virtually touring our lab, and we hope you get the opportunity to join us in person sometime in the future.